Okay, so next I would like to explain about basic buffer solution. So basically basic buffer solution ni you boleh prepare by mixing a weak base and its salt ataupun its conjugate acid. For example, if let's say you ada beaker and then dalam tu adalah basic buffer solution, makanya dalam ni mesti akan ada NH3 ataupun NH4Cl ataupun NH4+, because if you can see that if NH3 adalah weak base, okay, so dia punya salt adalah NH4Cl. How about dia punya conjugate acid? Okay, kalau weak base dia dissociate partially, dia akan add proton. Betul tak? So bila dia add proton, dia akan menghasilkan produk NH4+. Okay, so NH4+ ni lah conjugate acid kepada weak base NH3. So nak bagi tahunya, kalau you ada basic buffer solution, wajib you hafal dua equation ni, because these two equations adalah apa yang berlaku di dalam basic buffer solution ni. Okay, so these two equations, the first one ialah the dissociation equation untuk weak base, di mana dia dissociate partially in water, right? So dia akan menghasilkan conjugate acid NH4+ and also OH-. Okay, another thing ialah the dissociation of salt NH4Cl. Kalau salt dissociation memang dia occurred completely, makanya dia akan menghasilkan NH4+ and also Cl-. Okay, tapi if you want to know the amount of NH4+ ni, it depends on the salt NH4Cl. Okay guys, what will happen bila kamu add a small amount of acid di dalam basic buffer solution? Small amount of strong acid lah. Kalau strong acid ni biasanya kita symbolisekan dia dengan H+. Okay, so you kena ingatlah dalam basic buffer solution ada dua jenis equation yang berlaku. Yang pertama ialah the weak base dissociation equation. Yang kedua ialah salt dissociation equation. Okay, so apa berlaku kalau let's say you add a small amount of acid? Acid ni dia akan react dengan siapa? With whom? Dia akan react dengan base, dengan the weak base ni, okay? So what happened here? The small amount of strong acid yang added ni will be consumed by the weak base ammonia, so that dia boleh form conjugate acid NH4+. Okay, so when most of the acid added, it will be removed. It can only be removed this way, and as a result, there will only be small change in pH. So apa yang berlaku? Since that NH3 yang consumed, bila small amount of acid is added, the concentration of NH3 akan berkurang, tapi concentration of NH4+ akan bertambah. Therefore, direction will be shifted to the right. Okay, tapi yang pentingnya kamu kena tahu equation ni lah bila small amount of acid is added to the basic buffer solution. Ni penting ni sebab nanti kalau you nak buat calculation, you kena ingat this equation. So inilah yang Miss bagi tahu tu, yang dia punya reaction will shift to the right. So the concentration of NH3 berkurang, concentration of NH4+ bertambah. Therefore, as a result, there will only be a small change in pH. Okay, kalau let's say soalan tak minta kamu nak cari specifically the pH value, you boleh terangkan bila small amount of acid is added in the basic buffer solution dengan cara macam ni. You just bagi tahu tiga equation yang penting tu. This is the first equation yang penting, second equation yang penting, the third equation yang penting dekat previous slide tadi yang saya terangkan, di mana NH3 akan consume the H+, akan menghasilkan NH4+, and then you bagi tahu je lah yang ni, as a result, there will only be a small change in pH. Okay, so what happened bila kamu add a small amount of strong base to the basic buffer solution? Okay, strong base biasanya kita akan symbolisekan dia dengan simbol OH-. Okay, so this is what happened to the basic buffer solution. You kena ingat dua equation ni. Okay, yang pertama dia akan buat weak base punya partial dissociation, and also the complete dissociation of the salt. These two equations sangat penting akan berada pada basic buffer solution lah. Tapi bila you add a small amount of base di dalam basic buffer solution ni, I believe that the one yang akan react dengan OH minus ni ialah NH4+. Okay, so this is the equation yang terhasil. Okay, equation ni pun you kena hafal. This is the equation yang terhasil bila you add a small amount of base into the basic buffer solution, di mana NH4+ akan consume the OH minus added, the strong base added, dan akan menghasilkan NH3. Okay, plus H2O. Okay, so this is a conjugate acid. So bila dia add dengan the strong base, dia akan menghasilkan NH3 dengan H2O. So nak bagi tahu kat sininya, since that the conjugate acid ni yang akan consume the pertambahan OH lah, sebab bila you tambah OH, dia akan tambah dekat bahagian produk kan. So actually direction akan hanya mencapai equilibrium bila direction is shifted to the left. Okay, because if you look at this equation, bila you tambah OH minus ni, the product ni akan bertambah, so NH4+ ni akan try to consume the OH minus yang added supaya OH minus ni dia tak bertambah lebih-lebih lah, so direction will shifted to the right. Therefore the concentration of NH3 ni akan bertambah and concentration of H2O ni pun akan bertambah jugalah, manakala concentration of NH4+ ni akan berkurang. Okay, so you kena ingat tiga equation ni je bila small amount of base is added. Okay guys, so how can we find the pH of the basic buffer solution? Okay, so kalau you nampak basic solution, nak cari pH, bukannya simply you boleh cari pH. You kena guna formula. Formula apa? pH is equals to 14 minus POH. So sekarang ni, bila dah basic buffer solution, dia punya POH pun akan jadi different. How different it is? You kena follow the POH formula untuk basic buffer solution, yang di mana dia akan gunakan Henderson-Hasselbalch equation. So you just need to remember this ya. Sila hafal this POH formula according to the Henderson-Hasselbalch equation untuk basic buffer solution, di mana POH is equals to PKB. PKB ialah negative log KB pluskan dengan log concentration of conjugate acid ataupun dia punya salt, di mana if let's say you ada conjugate acid NH4+ ataupun salt NH4Cl lah, dia akan berada di atas concentration dia. Bahagikan dengan concentration of the weak base. If let's say in this case weak base yang diberi ialah NH3, so it maksudlah concentration of NH3. Okay. Okay, so let's look at this example. Dia beritahu a buffer solution is prepared by mixing 400 ml of 1.5 molar NH4Cl solution with 600 ml of 0.1 molar NH3. Okay, so kat sini dia beritahu buffer solution. Dia tak beritahu if either this is a basic or acidic buffer solution. So you kena tengok kat soalan ni. Okay, dia bagi NH3. NH3 ni you kena peka lah. NH3 ni is a common example untuk weak base. Okay, so kalau weak base dia NH3, dia punya salt dia adalah NH4Cl. Okay, so this is the salt for the NH3. So kiranya this will be a basic buffer solution. Okay, basic buffer solution di mana dia mix kan 400 ml and then 1.5 molar of NH4Cl and also 600 ml and 0.1 molar of NH3. Okay, so the question wants you to find the pH of the buffer solution. Again, kalau buffer solution you kena refer Henderson-Hasselbalch equation. Tapi since this is a basic buffer solution, you need to find the pOH dahulu. Lepas tu, pOH ni according to the HH equation lah. pOH of HH equation yang panjang lebar tu. Okay, lepas tu, you nak cari pH, barulah you gunakan formula pH is equals to 14 minus POH. Okay, and then next, dia suruh kamu calculate the pH of the buffer solution after the addition of a strong base, a small amount of a strong base, and then a small amount of strong acid. And then assume that the volume of the solution doesn't change when HCl dengan NaOH is added. So this will be fine for you. And dia bagi tahu nilai Kb is 1.8 times 10 to the power of negative 5 molar. Okay guys, so first the question wants you to find the pH of the buffer solution. So you kena kenal pasti buffer solution tu buffer solution apa. Tengok-tengok, oh it's a basic buffer solution. So nak kira pH, dia tak boleh lah ambil pH HH equation. Dia kena cari pH tu melalui pH is equal to 14 minus POH, di mana POH ni barulah kena guna POH of Henderson-Hasselbalch equation, di mana POH of HH equation ni ialah equals to PKB plus log concentration of salt ataupun conjugate acid divided by the concentration of the weak base. Okay, so from the equation you tahu di dalam basic buffer solution ada dua equation ni. Okay, so you kena ingatlah dua equation yang terlibat. Okay, lepas tu kalau let's say you simplifykan dia, you know that POH is equals to negative log Kb pluskan dengan log concentration of the salt. Okay, sebab dalam question tu dia bagi concentration of salt kan, NH4Cl, bahagikan dengan concentration of the weak base NH3. Okay, so once you have found the POH, you boleh guna this formula untuk find the pH value of this basic buffer solution. Okay, so from the question, dia bagi concentration of NH4Cl dengan NH3. Tapi volume mereka berbeza. So, bila you add these two things together in one beaker untuk menghasilkan basic buffer solution, you tengoklah volume of NH4Cl 400, volume of NH3 600. So, kalau 400 plus dengan 600 ml, that will make the whole volume of this basic buffer solution will be equals to 1000 ml, right? Tapi bila dia punya volume tu dah berubah, therefore dia punya molarity pun akan berubah. So you need to find the new molarity ataupun the new concentration for each of these things, which is you have to find the new concentration untuk NH4Cl and you have to find the new concentration untuk NH3. By using this formula ataupun equation, M1V1 is equals to M2V2, di mana M1V1 ni ialah original molarity and volume, M2V2 ni ialah new volume and new molarity. Okay, so kita boleh consider M1V1 ni as old, yang ni pula new. Okay, so for example, if you want to find the concentration of NH3, you masukkanlah kat M1 ni, molarity asal dia untuk NH3 ialah 0.1. Volume yang asal dia adalah 600. Okay, equals to, okay, Miss buat dululah kat sini biar kamu nampak 0.1, 600, lepas tu equals to M2. M2 ni new molarity, new concentration of NH3. Sebab the volume yang baru sekarang ni adalah 1000 ml. This is the V2. Okay, so volume yang baru sekarang ialah 1000 ml. Perlu ke Miss nak convert the unit? No, you don't have to, since that kita guna this one in milliliter, nanti dia boleh cancel out each other. Faham tak? Okay, so when you want to jadikan concentration baru NH3 as the subject, okay, it will be 0.1 kalikan dengan 600 bahagikan dengan 1000 ml. So ml will be cancelled out with ml and you akan dapat the value of the new concentration NH3 is 0.06 dalam unit M besar. Faham tak? Okay, so next we find the new concentration of NH4Cl pula. Okay, the old concentration of NH4Cl is 1.5. Okay, 1.5. The old volume ialah 400. So M2 ni is something that you need to find, the new concentration of NH4Cl. Okay, volume yang baru adalah 1000 ml. Okay, so again, when you make the M2 as a subject of the equation, so it's going to be concentration of NH4Cl ni in 1000 ml will be equals to 1.5 times with 400 ml bagikan dengan 1000 ml. So milliliter boleh akan cancel out dengan milliliter, therefore you will get the new concentration of NH4Cl ialah 0.6 molar. Okay, next, after you have found the new concentration for H, then you boleh cari POH according to the Henderson-Hasselbalch equation, di mana POH according to the Henderson-Hasselbalch equation is equals to negative log Kb, PKb kan? Kb kan dah diberi, which is 1.8 times 10 to the negative 5 molar. Okay, campurkan dengan log, okay, ni tulis kat atas ni lah, PKb, campurkan dengan log salt, concentration of salt bagikan dengan concentration of the weak base. Okay, so concentration of salt yang baru ialah 0.6, concentration of weak base yang baru ialah 0.06. So now we will get the POH value, which is 5.74, and then kita tahu kita nak cari pH. pH is equals to 14 minus POH, right? So this formula you gunakanlah untuk cari the pH value, di mana 14 minuskan dengan POH value according to the Henderson-Hasselbalch equation untuk basic buffer solution, which is sebanyak 5.74. Therefore, you will find the pH value is 8.26. Okay. So next, what happened to the pH of the basic buffer solution bila you add a small amount of strong base, which is 0.15 molar of NaOH. Okay, so sekarang ni you kena buat RICF table. Alright, so how about the reaction? The reaction tu kan Miss suruh kamu hafal apakah adjustment equation yang you have to do if you add a small amount of strong base to the basic buffer solution. Inilah dia, di mana dia punya conjugate acid. This is the conjugate acid. Okay, conjugate acid ni yang akan consume. Conjugate acid ni yang akan consume the strong base added. Okay, strong base tu NaOH lah, tapi kita dalam equation ni kita letak OH minus. Okay, and then nanti dia akan menghasilkan weak base and water. Okay, bila you buat reaction equation ni, you jangan lupa the phases here, di mana NH4 plus dengan OH minus, NH3 semua in aqueous phase, H2O saja in liquid phase. Okay, tapi you kena ingat reaction ni, this is the reaction equation bila you add a small amount of strong base into the basic buffer solution. So you kena buat ICF table because you need to know the final concentration after you add 0.15 molar NaOH to the basic buffer solution. Okay, and also you can assume the X value is equals to the concentration of the strong base yang added to the basic buffer solution. So first thing first, let's figure out the initial concentration untuk conjugate acid. Okay, how can you find the initial concentration of conjugate acid NH4+? You can find this from where? From NH4Cl. Kan information ada bagi tahu concentration of NH4Cl berapa. Ni new concentration tau. Bukan kamu ambil yang dalam soalan. This is a new concentration after you have calculated bila dia ada 1000 ml in the beaker. Macam tu. So, this is the new concentration of NH4Cl if the solution is made up to 1000 ml, which is 0.6 molar. Tapi you boleh samakan lah concentration of conjugate acid NH4 plus dengan NH4Cl, which is 0.6 molar. How about concentration of OH minus? OH minus ni ialah strong base yang added tu lah, which is 0.15 molar. Okay, concentration of weak base, this one is 0.06 molar. This one you dah kira. This is the concentration of weak base Kalau let's say ada 1000 ml in the solution, which is it will be 0.06 molar. How about the change? Okay, the change kalau let's say dia dekat bahagian reactant, as usual is gonna be negative X. Okay, kalau let's say dekat bahagian product is gonna be positive X. Alright, and then since that kita dah assume kat sini, sebab itulah pentingnya kalau you buat assumption, you kena nyatakan. So you have assumed that the value of the concentration of X will be equals to 0.15 molar. So kalau let's say untuk reactant, negative X will be negative 0.15 molar lah. Okay, so dah boleh padam ni. Untuk product, it will be positive 0.15. So I can erase this as well. So the final concentration will be the summation of these two things. Okay, so the final concentration of the conjugate acid ialah 0.45, and then the final concentration untuk the base adalah 0.21. So sekarang dia nak suruh kamu cari the pH of the buffer solution when 0.15 molar of NaOH is added. So that's why you need to find the pOH dahulu melalui equation Henderson-Hasselbach. Okay, so you masukkan saja nilai-nilai yang dinyatakan. Okay, kalau Kb dah dibagi tahu kat sini, this is pOH equals to pKb kan, pluskan log conjugate concentration of conjugate acid. This is concentration of conjugate acid yang final, which is 0.45, and then this is the concentration of weak base yang final, which is 0.21. Therefore, you will get the pOH value after a small amount of strong base added to this basic buffer solution is 5.08. To find the pH value, you need to use the formula pH is equals to 14 minus pOH, di mana kita dah dapat pOH value, so kita 14 minuskan dengan 5.08, therefore you will get the pH value adalah 8.92. Okay, let's see what is the pH of the basic buffer solution bila kamu add a small amount of strong acid, which is 0.011 molar of HCl. Okay, so sekarang ni you kena hafal apakah reaction yang berlaku, apakah equation yang berlaku bila you add a small amount of strong acid to the basic buffer solution. That's why Miss suruh hafal kan. Okay. So, kalau you hafal, nanti you boleh terus senang letak dekat bahagian reaction ni. Di mana, bila you add a small amount of strong acid to the basic buffer solution, okay, siapa yang consume? The weak base will consume it. Okay, so weak base will consume. This weak base, dia akan consume the small amount of the strong acid. Walaupun HCl, you letak sajalah simbol H+, okay. And then dia akan menghasilkan conjugate acid NH4+. Okay, so next you kena buat ICF table. Okay, the initial concentration of weak base kita dah calculate before this. Okay, which is 0.06 molar. And how about the concentration of HCl? You masukkan dekat bahagian H+ ni, which is 0.011. The concentration of the conjugate acid NH4 ni, you can find it from NH4Cl, which kita dah calculate dah concentration new of NH4Cl for 1000 ml berapa kan, which is 0.6 molar. And then kita, once you have assumed, you kena assume yang addition tu is equals to the X value. Okay, so kita tahulah kalau concentration yang change untuk reactants is gonna be negative X. Kalau untuk product is gonna be positive X. Since we have assumed, okay, benda kalau you assume pun you kena bagi tahu. Since you have assumed the X value will be the concentration of the addition strong acid ni, which is 0.011. So, kalau untuk reactant, the change concentration untuk reactant will be negative 0.011. Okay. Kalau product pula is going to be positive 0.011. Okay. And lastly, the final concentration for each of these species will be, kalau NH3, you tambahkanlah 0.06 dengan negative 0.011. So, you will get 0.049 molar. Okay. and then the concentration untuk conjugate acid pula ialah 0.611 molar. Okay, so the question wants you to find the pH, but you need to find the pH through POH dahulu. So this is the POH equation from the Henderson-Hasselbalch, di mana POH is equals to negative log Kb. Kb value kita tahu. Okay, campurkan dengan log concentration of the conjugate acid. This is the final concentration of conjugate acid that we have obtained here, which is 0.611, divided by the concentration of the weak base that we have obtained at the final concentration, which is 0.049 molar, and therefore we will get the POH value is 5.84. And after that, we know that to find the pH daripada POH is going to be pH is equals to 14 minus POH. Okay. So 14 minuskan dengan 5.84, therefore you will get the pH value after pH value of the basic buffer solution after a small amount of strong acid is added is 8.16. Okay guys, next, this one pun soalan tak minta tapi Miss saja nak ulas saja. Okay, as you can see, bila kita calculate the pH of the basic buffer solution, for example previously, before you add a small amount of strong acid ataupun base, the original pH value of the basic buffer solution is 8.26. Tapi bila you add a small amount of strong base to the basic buffer solution, the pH is 8.92, which is ada slight change kat situ. Tapi bila you add a small amount of strong acid to the basic buffer solution pun, the pH value is 8.16, which a slight change je lah kepada original pH buffer solution. Therefore, it fits with the narration that buffer solution ni ialah solution yang di mana dia boleh maintain dia punya pH bila a small amount of strong base atau acid is added to the solution. Okay?